Okay, so just a friendly reminder, these are all of the topics that will show up on your guys' final. Let's start with Chapter 5. Okay. It's been a while since we've covered this. Do you guys remember going over probability? Okay. So the first thing you guys need to know about probability, this will be Unit 5 review. First thing you need to know is that probability is not guaranteed. Okay. So just because there is a 1 out of 6 chance that you're going to roll a 2 on a dice does not mean if you roll the dice 6 sides it'll only happen once. It also does not guarantee over 6 rolls you'll get every single number at least once. Okay. There's also a difference between independent and non-independent. Okay. If probability is independent, that means that one event does not affect future events. So some examples of independent probability. Can you guys think of any examples off the top of your head? Flipping a coin. That's independent because every single time I flip the coin, it's going to be 50-50. Right? So an example of independent would be flipping a coin. Any other ideas of examples?
Rolling a die.
Rolling dice. Okay, those probabilities do not change. Okay. I'll do some non-examples. If you guys were playing with a deck of cards and you were not replacing them, okay. So an example of this would be like, okay, let's say you have a deck of cards, you're trying to pull an ace of spades. There's one ace of spades out of 52 cards. You pull a card, it's not the ace of spades. You pull it again, is your probability still 1 out of 52? It becomes 1 out of 51 next, right? So that's an example of it being not independent. The probability changed on the next card. Okay, so I have some example problems for you guys. This is just going to be true or false. Okay. First situation, you flip a coin. And you get tails 9 times in a row. That means you're more likely to flip heads the next time. Okay, so this is a true or false example. You flip a coin and you get tails 9 times. That means you're more likely to flip heads the next time. Is that true or false? Tell your partners around you. Okay, correct. It is false. That is false because each flip is always 50-50. Okay, here's another example. when flipping a coin 6 times, going heads, tails, heads, tails, heads, tails, is equally as likely as tails, 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 tails. Is that true or false? Ask your neighbors around you. Think about it. Is it just as likely? Okay. Order matters here. Okay, so these are just as likely. I was 50-50 on getting heads or tails the first time, 50-50, 50-50, 50-50, 50-50, 50-50. So these are equally as likely. Okay. One more example. Okay. You guess a card with replacement, meaning after you pull a card, you put it back in the deck, is red or black. You will get 5 red and 5 black from 10 cards. So you're pulling from a deck of cards. You know it's going to be either red or black. Okay? And if you pull 10 cards, that means you're going to get 5 red and 5 black. Is that true or false? Okay. False. It is likely that that will happen, but it's not guaranteed. Okay. Now, if I were to change this to say you were expected to get 5 red and 5 black, is that true? Okay. We expect to get 5 red and 5 black. However, it's not definitive. We aren't guaranteed. So those are the words on this test. I'm dead serious. You have to be very careful. You have to read very, very carefully. There's at least 5 multiple choice problems when I was going through this, when I looked at it and I went, oh, is that the same answer? And no, it's not the same answer because there was one little word that made a difference. Okay, next up. Okay. Multiple events. So for this situation, I couldn't think of a way to teach it, so I'm just going to use an example. And this example will show up pretty similarly on your test. Okay. There are 20 students. Okay. 10 girls and 10 boys. If randomly selected, what is the probability the first 3 students are boys and the next 2 are girls? So take a minute, talk to the people around you. How would you set this up? Okay, so let's think about the first person we put. Remember how we said we're going to basically do multiple events together? The first event, okay, if we're doing the first student, how many students are there? 20. Okay, and we said what is the probability that the first 3 are boys? So if I'm picking the first student, how many boys do I have to pick from? 10. So it's 10 out of 20. Okay, now we're going to do times, and now we have the second student. So I've already picked one student. How many students are left? 19. All right, and I've already picked one boy, right? So how many boys are left? 9. So then what would the next fraction be? 8 out of 18, because out of 18 boys left, or sorry, out of 18 students left, 8 are boys. Okay. Now remember, I'm picking 5 total students, and so far I've done 3 students. Okay, each of these is a fraction for each of the students. So for my next one, after my first 3 are boys, I next need to pick a girl. So what is my next fraction going to look like? It's going to be 10 on top, because now I have 10 girls remaining, but I only have 17 total students left. Okay. And I have to pick one more girl. So after 10 girls, that means there's 9 remaining out of 16 remaining students. Okay. On the test, they won't actually make you put this into your calculator. They'll just have you set it up like this. Questions, comments, or concerns on this one? Okay. More rules about probability. Probability must be between what 2 numbers? 0 and 1. You can't have negative probability, and you can't have more than 100% chance. Okay, so it must be between 0 and 1. Okay, and all probabilities must add to what number? Okay, all probability must add to 1. So let's say we're looking at a table. On the x-axis, we'll do number of TVs, and the y-spot will do probability. And let's say people have either 0, 1, 2, 3, or 4 TVs in their house. And let's say we got 0.1, 0.1, 0.3. We don't know what that is, and this is 0.4. Okay, find the probability of having 3 TVs. Should only take you a couple seconds. Alright, what'd you guys get? 0.1. Okay, and that's because all probability must add to be 1. So if we did 1 minus 0.4 minus 0.3 minus 0.1 minus 0.1, that's how we would end up with our other 0.1. Okay, that's how we found the missing piece. One more thing based off of this. What is the probability of getting at least 2 TVs in the house? Okay, the probability of getting at least 2 TVs in the house. Okay, and again, very basic math. We're not trying to go crazy with this. Okay, probability of at least 2 TVs. So that means you have either 2 or 3 or 4 TVs in the house, right? So that means you would do 0.3 plus 0.1 plus 0.4, which would come out to a 0.8 probability. Thumbs up if we're feeling good about this so far. Alright, if you're feeling good about this, then that means you guys will ace the first 4 questions of your final. Okay. More probability. Okay. General rule for probability is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay. You could also use a Venn diagram for it too, if you would like. So, for example, let's say 50% of people prefer chocolate, ice cream, 30% prefer vanilla, and 10% prefer both. What is the probability a student prefers chocolate or vanilla? Alright, give it a try. See what you guys get. Alright, anyone more time? Okay, so in this case, probability of A. What's the probability someone prefers chocolate? 50. Okay. Plus, what is the probability they prefer vanilla? 30, or 0.3. Minus the probability they prefer both, because you don't want to count someone twice, right? So what's the probability they prefer both? 10. So that means there is a 70% chance, or 0.7, that they prefer chocolate or vanilla. Thumbs up or thumbs down? Alright. So, what AP test is going on right now? Right now? Something's going on right now. Econ's later. There's also swimming. Yeah.
Are you taking it? Not if it goes to green. You are.
Alright. So, based on these responses, so we're going to make a two-way table real quick. Okay. Let's do, in my stats classes, I have either juniors or seniors. And in this class, I either have people who have only gone up to Math 3, or I have some students who have taken beyond Math 3. Meaning they've taken advanced math, calculus. Okay, that's the different kind of students that I get in this class. Okay. So in total, for juniors, I've had, let's see, I've had three, let's go one junior who's only taken Math 3. I have 4 who have taken beyond. And then just for the sake of making the numbers pretty, for seniors, I have 29 students who have taken up to Math 3. And I've had 16 students who have taken beyond. Which means for my total, I've had a total of 30 people take Math 3 as their highest class, 20 taken beyond. I have a total of 45 seniors and 5 juniors for a grand total of 50 students in stats. So we've got some probabilities to calculate. What is the probability that a student has taken at most Math 3? It's just a chart. It'll probably look more like this on your test. Okay, so probability of Math 3. How many people have taken only up to Math 3? 30. Out of how many total students do I have? 50. So 30 divided by 50 would give me a 0.6. Okay, and that's just how you do regular probability. Okay. If you guys were to do and probability, okay, notice how we got this number on top from a total column. Okay. If you were to do, what is the probability that someone is taken beyond Math 3 and is a senior? Okay, so beyond and senior. So when you guys are dealing with and probability, you guys are only looking in the table, like in the guts of the table, in the middle. So this is someone that is beyond and a senior. So how many people are both beyond and a senior? 16. So that's still 16 out of 50, which will give us a 0.32 probability. And another thing you have is what's called conditional probability. Conditional probability says the probability of A given B is equal to the probability of A and B divided by the probability of B. In other words, most of your probability you're going to divide by the grand total of 50. But there's some situations where you are not going to divide by that. Because what if I'm not talking about all of my stats teachers or students? What if I'm only talking about seniors? What if I'm only talking about the people who went beyond Math 3? So an example of this, we have the problem of what is the probability that a randomly selected student is a senior if we know they've taken beyond Math 3. So I'm going to show you guys the long algebraic way to do it that follows the formula, and then I'm going to show you guys like the Bringhetto version of how to do it. Okay, so the way to do it with the formula, the probability of A and B. So what is the probability that they are a senior and taken beyond Math 3? That's 16 out of 50, right? So we're looking at the probability that they are a senior and beyond divided by the probability. We know they've taken beyond Math 3, so that's probability of beyond. So senior and beyond, that was a 16 out of 50. Probability of beyond, so there's a total of 20 people who have gone beyond, so that would be 20 out of 50. And because you're dividing by a fraction, you just got to flip and multiply. It's pretty flippin' easy. Don't flip and overthink it. Okay, just flip and multiply. So this will be 16 over 50 times, we're going to multiply and flip that fraction of 50 over 20. These 50s will cross out, and we get 16 over 20, which comes out to a 0.8 probability. Okay, so that's doing it with the long way. Here's the Brungetto way to do it. It says if we know they've taken Beyond Math 3, if we know that they've taken Beyond Math 3, then that means I am only going to look at the Beyond people. I'm going to cover everything else up. Okay. So out of those 20, how many are seniors? 16. 16 out of 20, same answer. All right, any questions on using the probability table? Okay. All right, I don't know if you guys know this, but we're hiring for a new math teacher. Okay, and we had 20 people apply. So this is another example. Okay. Applied to be a math teacher. Okay. And Mr. B will interview the same amount of candidates every day next week. How many different possibilities can be interviewed on Monday? Sorry. So 20 people applied to be a teacher. We'll interview the same amount of candidates every day next week. How many different possibilities can be interviewed on Monday? So, again, this is hard to teach. It's better just to teach by an example with this example problem, right? It helps if you do it candidate by candidate. Remember how we do multiple events? So this is an example of a permutation. How many people did we interview on Monday? If 20 applied, we're going to interview the same amount every single day. 4 people, right? We're going to interview 4 people. Okay. So 20 divided by 5 means we interview 4 people on Monday. Okay, that's not our answer. That's just telling us how many people we're going to pick from. So, our first candidate on Monday, how many people do we have to pick from? We have 20 people to pick from. Our second candidate, how many people do we have to pick from? 19. And our next candidate? 18. Our next candidate? Our next candidate for Monday? No, we stopped. How many people are we interviewing every day? 4. And these are our 4 people that we're interviewing on that Monday. So that means that when you multiply these numbers all together, 20 times 19 times 18 times 17, whoops. We end up with 116,280 different possible combinations. And again, that's because we interviewed we had 20 people to pick from the first interview, 19 to pick from the second, 18 to pick from the third, 17 to pick from the fourth, and then we stop interviewing because we're only looking at Monday. We're only interview 4 people that day. Okay, we're going to go back and look at the balloon problem from a while ago. Okay. Remember, the probability of at least 1 is equal to 1 minus the probability of none. None means 0 is going to happen. At least 1 means it could be 1 or 2 or 3 or 4 or 5 or up to however many you do, right? So for our example, okay, the probability a balloon will pop is, let's go, 0.2. If Mr. B buys 3 balloons, I think I'm spelling balloon wrong. If Mr. B buys 3 balloons, that's what I thought. Too late, I'm sticking to it. I'm committing to being an English degenerate. That's why I failed AP Lit test. I got a 2. I didn't completely fail it. If Mr. B buys 3 balloons, what is the probability that all 3 will pop? Okay. Get out your calculator and give it a try. There's a 0.2 probability that it'll pop. What is the probability that all 3 of my balloons will pop? If Mr. B buys 3 balloons, what is the probability that all 3 will pop? Okay. So let's think of it in terms of individual events. How many events are going to happen? 3, right? So the probability that one of them is going to pop is going to be 0.2, right? That's event 1. And then the next event, the probability it's going to pop is 0.2 again, right? And the probability the third one's going to pop is also 0.2. You could just write that down as 0.2 to the 3rd power. Put that into your calculator. And we get 0.008. So that means there is a 0.8% chance that all 3 of my balloons are going to pop, and poor Emmy does not get a birthday balloon on her birthday on Saturday. My daughter just turned 1, like 2 days ago, so. She has a little party. The theme is Sun Bunny's turning 1. Oh yeah. She's cute. She's also a little tear. I was eating a Rice Krispie treat and she was crawling around the floor and she saw I had a Rice Krispie treat and she started yelling and grunting at me and chasing me because she wanted me to give her some. Okay, so that's the probability that all 3 balloons will pop. Okay, well then, what is the probability that no balloons pop? Okay. What is the probability that none of the balloons will pop? So we got to do a little bit of work here. Again, how many events do we have? 3 events. We're still dealing with 3 different balloons, right? So if there's a 0.2% chance that it does pop, what is the chance that it does not pop? 0.8. So we're going to start off by doing a 1 minus 0.2, which gives us a 0.8, which means there's a 0.8 chance the first balloon does not pop, a 0.8 chance the second balloon does not pop, a 0.8 chance the third balloon does not pop, which is the same as saying 0.8 to the third power. And we get 0.512. Now the last question, what is the probability that at least 1 balloon pops? So remember, we have the formula that's right up here. It's the probability of at least 1. At least means it's 1 minus the probability of none. So there is a 0.512 chance that no balloons pop. That means that there is a 1 minus 0.512 chance that at least 1 will pop. And that should give us 488. Alright, so let's summarize what we learned today, or that we went over. We talked about probability not being guaranteed, correct? Okay, just because you flip a coin 10 times does not guarantee you're going to get 5 tails and 5 heads. Okay. We also know that probability is independent. So just because if you're an 80% free throw shooter and you make 10 free throws in a row, the probability you're going to get the 11th free throw is what number? Is 80%. Okay? Because it does not change. It's independent of the others. Okay. We did the formula for probability for OR. Do you guys remember that off the top of your head? What is the formula for OR probability? Like the probability of A or B is what?
A plus B minus A and B.
Correct. A, probability of A, plus the probability of B, minus the probability of A and B. So that was this formula right here. Okay. We also have the two-way probability table where we worked on. Remember, when you guys are doing at least, probability must always be between 0 and 1, and the probabilities must all add to 1. One of the problems on your final will give you 4 different tables like this, and they'll say which one of these tables is appropriate. They'll give you one of them with a negative. They'll give you one of them where they're all equal to 0.5, where they don't all add to 1. So we got to make sure that we find the ones that work out. Okay. We did two-way probability table. So going back over here. Remember that most probability divides by 50 until we get to conditional probability, where we basically cover up everything besides what we know for a fact. So if we know for a fact that someone is a senior, like let's say, what's the probability that they've only taken Math 3 if we know they are a senior? If we know they're a senior, we only look at the seniors. Only Math 3 means we do 29 divided by 45. Okay. Again, that's only if you know for a fact. Otherwise, if it's an and, you look in the inside of the table. Or if you're just doing straight up probability, you do the total divided by the grand total. Okay. We talked about doing many different interviews. Okay, and we are only doing a certain amount. So when we're talking about how many different possibilities that we could have, you start with how many possibilities for the first person, for the second person, for the third person, and the fourth person. You don't keep going because you can only interview so many people per day. You're going to stop at a certain point. Okay. And we got this formula right here, which is where at least one is 1 minus the probability of none. Friendly reminder, examples cannot be on your card, on your index card. You guys can write this formula right here. I encourage you to write this formula. You guys could write this formula for conditional probability if you want. If you guys want to write a little note to yourself that says when it's conditional, just cover up what you're not looking for. It's a little note you can write to yourself. I'm okay with that. On your note card, this formula for or probability would be pretty good for you. These reminders for yourself would be good. Okay, no worked out examples. These, I'm okay with this. Okay, these aren't necessarily worked out examples, but putting an example of independent and then not independent, I'm okay with that. Okay. And again, I'll be giving you guys your card once we've gone over all the reviews. Okay. Questions, comments, or concerns? Current events. Alright, so we have Unit 5 today. We'll probably do Unit 6 on Monday. We'll try to do Unit 7 on Tuesday. I know it's golden hour day. Maybe do 8 and 9 on block day. You guys will make a mock final. So you guys are going to basically try to make something yourself. So you guys will take each other's mock finals. There is going to be a sapling assignment for Unit 5 reviews. Okay, I'm going to activate it right now.